Hello students, let us see our next example of curve tracing. Trace the curve xy square is equal to a square into bracket a minus x, where a is greater than 0. First point is symmetry. As usual, we have seen in this equation the powers of y are even, that's why even powers of y, the curve is symmetric about obviously x-axis. Next, origin. Put x is equal to 0 and y is equal to 0, we get 0 is equal to, here 0, a into a square is a cube. And in the example itself, a is greater than 0, that's why it is not possible, that's why the curve is not passing through, doesn't pass through origin. Next, point of intersections on coordinate axis. Put x is equal to 0 in the given equation, what we get? 0 is equal to this 0. Again we get the same equation, which is not possible, that's why we don't get this point. Now put y is equal to 0, second point, we get here y is equal to 0, a cube or a square into a minus x becomes 0, that's why a can't be 0, that's why a minus x becomes 0. Okay, therefore a is equal to x, that means x is equal to a is the point of intersection where y coordinate is 0, therefore point of intersection is a 0, x and y coordinate a is 0. Okay, now we have to find out tangent at this point. Tangent at above point, we have to find out dy by dx. For that we have to differentiate this equation with respect to x. For that, take a square inside, we get xy square is equal to a cube minus a square x. Okay, now differentiate with respect to x, we get, this is the product rule, we have to use product rule here. U into x into derivative of y square is 2y into y derivative becomes dy by dx, should be multiplied by chain rule. Okay, plus v into, that is y square into derivative of x is 1. This is u into v rule completed here, is equal to, now RHS side x is there, a cube is constant, that's why a cube derivative is 0, minus a square as it is, x derivative is 1. Okay, now we have to find out dy by dx, that's why arrange this term on RHS side, we get dy by dx is equal to minus a square minus this y square upon this 2xy. Okay, now we have to put this point coordinate in this dy by dx. Now put a0 is equal to in this value dy by dx at point a0 is equal to, y value is 0, that's why it becomes anything upon 0 is infinity. That's why tangent, what is the interpretation of when dy by dx comes to infinity? Tangent is parallel to y-axis at that point, which point? a0. This is the interpretation. Okay, now we have to one by one draw the curve. This is x and y-axis. Okay, now what is the symmetry? Symmetry about x-axis means x and y-axis, on above the x-axis there is a mirror image below the negative x-axis, negative y-axis. Therefore symmetry is about x-axis. Now origin, it doesn't pass through origin, that's why origin is not a part of curve. Okay, point of intersection, we have one point a0. Plot this point a0, this is the point on the curve. Okay, now we have found out tangent at above point, tangent parallel to y-axis at the point a0. a0 we have to draw the tangent which passes through point a0 and which is parallel to y-axis. That's why this is the line which is parallel to y-axis and it is the tangent line. Okay, if it is tangent at this point, therefore it means the curve is like this or like this. Okay, now next, asymptote. Coefficient of highest power of x should be 0. What is coefficient of highest power of x? This is the simplest form. X has two terms. Okay, x raised to 1, x raised to 1 is only highest power and its coefficient is y square. This minus a square comes to this way, we get plus a square. This means this is the equation like xy square minus plus a square x is equal to a cube from this. Okay, now take common x from this, we get coefficient y square plus a square. It must be equal to 0, we equate this equal to 0 to get asymptote, but y square becomes minus a square which is less than 0 and square of any number is not negative, can't be negative, it must be a positive for our theory. That's why no asymptote parallel to x-axis we get. Now next, similar way, coefficient of highest power of y, we have to put it equal to 0. What is highest power of y in this equation? There is only one term which is highest power of y, its coefficient is x. That's why x is equal to 0. We get the variable x is equal to 0. That's why y-axis, x is equal to 0 is the equation of y-axis. That's why y-axis is the asymptote. That's why here this line y, that is x is equal to 0, is the asymptote. That's why curve must be like this or this, this or this. This is the asymptote line format. Okay. Now next, region of absence. Now we get from here region of, we get three regions, 1, 2 and 3. Okay, for this region, this is obviously origin 0, 0. Okay, this is the region for x less than 0. Okay, for x less than 0, take any point on this side, that is minus a. We have put x is equal to minus a in above equation of curve, where y square is a square. Take x on the denominator only, we get this y square. Put x is equal to minus a here, we get this value which is equal to minus 2a square, which is negative, and square is again negative, which is not possible. That's why curve is absent in the region. That's why we have to rub the part where we have draw in this region, the part of curve. Okay, now next, for the curve between this, obviously if it is present, it is absent in this region, obviously we have drawn these two possibility, therefore it must be present in this region. Okay, you can directly write down the present in this region, where this is the simplification. For this region between 0 to a, this is 0 to a, put x is equal to a by 2, we get the positive value. That's why curve is present. Again, we have drawn this or this. That's why if it is present in this region, that's why it is must absent in this region, because it is the two possibility of tangent. That's why this we have to rub. Okay, and ultimately for this region, this is the explanation. For this region means this is greater than a region, means put x is equal to, x is greater than a, put x is equal to more than a number is 2a. We get this simplification. It is again negative. That's why curve is absent here. Curve absent. Okay. Now in this region, in this way, if it is absent here, this is only present here, we have to just draw this curve like this with free hand. The curve is like this. Okay, this is the final curve. This is the rough work. This is the final curve, where it is asymptote. X is equal to 0 is the asymptote. This is the tangent line at x is equal to a, that is x is equal to this is a perpendicular line to the coordinate axis, x-axis. This is the point a0, and this is the symmetric curve about x-axis. Okay. Now let's see next curve. This is homework for you. Y square x square is equal to x square minus a square. Okay. This is the answer for this curve. This is the curve. This one and this one is the curve, where y is equal to minus 1 is this line asymptote, y is equal to plus 1 is this line asymptote. That's why it is like this. Okay, and a0 and minus a0 at the point of intersection, and we have, these are four regions, 1, 2, 3 and 4. In this region curve is present, that's why we have to rub this region. In this region curve is absent, that's why we have to rub this region whenever possible curves we have we are supposed to draw. And in this region curve is present, and obviously the symmetry is about both x and y axis, because even power of x and even powers of y are there. Okay, it is a homework for you. Now let us see next example. This is important, it is a little different example. X raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3, where indices of the variables are fractions. This is the only example throughout the chapter where indices are fraction. Let us see. This is a special example. Make it star. Symmetry. Now how to calculate even powers, because all the powers are fractions. That's why we have to make one adjustment here. X raised to 2 by 3 becomes x raised to 1 by 3 square. Okay, here again x raised to 1 by 3 its square, or you can write x square raised to 1 by 3 plus y square raised to 1 by 3 in both way. Okay, that's why even powers of we get y and x both, even powers of both x and y. Therefore symmetry about both the axis, x and y axis. And even if you replace x is equal to y and y is equal to x in this equation, we get the same equation, because x, if you replace x is equal to y is equal to x, the equation remains unchanged. Therefore it is symmetry about the line x is equal to y also. Again, if you replace x is equal to minus x here and y is equal to minus y here, the powers are even. That's why it becomes minus x becomes plus x, minus y becomes plus y. Equations remains unchanged. That's why it is symmetric about opposite quadrants also. Okay, it is a standard example of all symmetry. It is a symmetry about axis also. It is symmetry about the x is equal to y line also, and it is symmetry about the opposite quadrants also. Okay. Now next, origin. Put x is equal to y is equal to 0, we get 0 is equal to a raised to 2 by 3, which is not possible. That's why it is not passing through origin. Now next point is point of intersection. Put x is equal to 0, we get y raised to 2 by 3 is equal to a raised to 2 by 3, and take cube to cancel 1 by 3 on both side, we get cube on both side, we get y square is equal to a square. Therefore take square root on both side, we get y is equal to plus minus a, that is a and minus a. Therefore points becomes x is equal to 0, y is equal to a, x is equal to 0, y is equal to minus a. These are the two order pairs. We get point of intersections. Okay, therefore we have to draw similarly this also. Put y is equal to 0, we get x raised to 2 by 3 is equal to a raised to 2 by 3, similar like this only. Therefore x becomes a and minus a. The order pairs are a 0 x and y, minus a 0 x and y. Okay, these are the 4 point of intersection we get. Now we have to plot the points. Suppose this is a 0, and this distance must be same as this. This is 0 a, this distance must be like this. Okay, it is minus a 0. Just make sure you are using scale. Okay, like we have already studied so many curves where you have draw the curves using scale only. By measuring the distance, you have to take up this a we don't know, a is only greater than 0 number. That's why according to, you have to make sure that your curve should be in the half page of the answer sheet. That's why according to that take a as 4 centimeter or 5 centimeter. Okay, if it is you are taking this particular distance, same distance you have to take here and here and here also. Okay, make sure that. Therefore these are the point of intersections. Okay, curve is symmetry about all the this thing. Okay, now let us see next. Once you get point of intersections, we have to find the tangents at above all 4 points. For that differentiate, we have to differentiate the given equation with respect to x. This is the equation. Differentiate given equation with respect to x, we get x raised to 2 by 3 derivative is x raised to n, derivative should be applied n into x raised to n minus 1. Therefore it becomes 2 by 3 into x raised to 2 by 3 minus 1 is minus 1 by 3, plus y raised to 2 by 3 derivative is 2 by 3 into y raised to minus 1 by 3 into y derivative should be multiplied dy by dx is equal to a derivative is a constant, derivative is 0. Okay, now take 2 by 3 cancel throughout the equation because RHS side is 0. We get x raised to minus this as it is, this term as it is. Now we get dy by dx by arranging this term. We get this term becomes on the RHS side becomes minus x raised to minus 1 by 3 upon this term becomes y raised to minus 1 by 3. Make sure your indices must be positive. Okay, that's why take y raised to minus 1 by 3 in numerator and x raised to minus 1 by 3 becomes comes in the denominator as a positive indice. Okay, this is we get dy by dx. Okay, now we have to put all these 4 points in this dy by dx and calculate whether the points dy by dx become 0 or infinity. Now put this point first, a0, y-axis, y coordinate is 0, that's why in the numerator y is 0, denominator whatever it is, the numerator becomes 0, that's why dy by dx at these 2 points become 0. What is the interpretation then? Tangent is parallel to x-axis at these points, 2 points. This is the interpretation. Now put these 2 points in the dy by dx. X-axis is 0, x coordinate is 0, that's why denominator becomes 0, it becomes infinity for both obviously. That's why for these two both points, tangent is parallel to y-axis at this point, 0 and 0 minus a. These are the 4 tangents we get. Now how to draw this tangent? First, at point a0, tangent is parallel to x-axis. This is the point a0 and tangent is parallel to x-axis means this is the point itself on the x-axis, and we have to draw the line which is parallel to x-axis and passing through this point. That's why x-axis itself is the line, tangent line, because any line is parallel to itself only. That's why this is the tangent line, x-axis. Okay, that's why if this is tangent to this point, then the graph should be like this or like this, right? It is a tangent line. Now similarly, minus a0 is also tangent parallel to x-axis from this point. Minus a0, we have to draw the tangent passing through this point, and parallel to x-axis means x-axis itself is a tangent to this point. This is the only line, that's why this is the curve or this is the curve. Okay, similarly 0a, from 0a point, that means this point, okay, we have to draw the tangent line parallel to y-axis. Now this is the point from which we have to draw the line which is parallel to y-axis and passing through this point. This is the only y-axis itself. That's why this is the y-axis tangent to this point. That's why curve should be this or this. Okay. And similarly, this one, 0 minus a, tangent parallel to y-axis. 0 minus a is a point this. And tangent parallel to y-axis from passing through this point is itself is a y-axis. That's why these are the curve. You don't need to see this 3 if you draw this, because curve is symmetric about x and y axis. That's why if it is like this, then on the RHS also, LHS also, curve is symmetric on y axis. That's why it must be like this only. And x axis is symmetric about x axis also. That's why if we draw this, again it is same like this. Okay. From symmetry also you can predict the rest of the 3 if you know 1. Okay, this is the explanation for detailed explanation for the tangent. Okay, now asymptote. There is obviously no asymptote, because for asymptote we have to find out highest power of x. This is the power of x, highest power. Its coefficient is 1 and 1 cannot be equal to 0. That's why no asymptote parallel to x-axis. Highest power of y is this term, and its coefficient is 1. That's why again 1 cannot be equal to 0. That's why no asymptote parallel to y-axis. That's why no asymptote. Now region of absence. We have to see, it is a particular example where we are going to see the region of absence quadrant wise, because there is no tangent lines, are only x and y axis. There is no other lines. Okay, in earlier example also, few examples, there are no tangent lines, only one tangent line or two tangent lines are there, where we have studied 0, less than 0 and greater than 0. But in this case the curve is absent in each line, each this 4 quadrant. That's why we have to check whether the curve is present in first, second, third or quadrant wise. Okay, now what is the procedure for finding the curve is present or absent in the quadrant wise? We have to make sure, see, our equation of curve is x raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3. Okay, now in this first quadrant, x values are positive and positive, x and y is positive. In this second, x is negative, y is positive. In this third, x is negative, y is negative. In this last quadrant, x is positive and y is negative, right? If you put positive sign in this equation, it becomes whatever x is negative or positive, the equation of curve is x square and y square. That's why whatever x is positive or negative, or y is positive negative, irrespective of that, everything becomes merged in the example and equation becomes unchanged, or positive sign remains unchanged on both the side. Positive becomes positive, and again RHS side becomes positive. That's why positive sign unchanged on both the side. That's why curve is present in first quadrant, second quadrant, third and fourth quadrant. It is present in all the quadrants. Understand? Because whatever plus sign, for plus sign it is plus again equation satisfied by sign, and for negative, whatever the negative x or y, x square is there in this simplified form of equation, okay, and y square is there. That's why a negative square is positive. That's why again our equation remains unchanged, or it doesn't change its sign on both the side. Sign becomes same, positive. That's why equation, if it is like this, then curve is present quadrant wise. Okay, now if it is present in this quadrant, we have to draw the lines. Now see, this is the line we have to join with this or this. Obviously this can't be go like this, it must be the freehand curve. That's why it must be like this. We have to draw like this only. Okay, that's why we have to cut this line, half line, and obviously you have to cut this line also. Only curve is this. Okay, nature of curve is as at point is points are tangential curve. That's why this is the curve. Now it is symmetry. That's why it must be like this. You have to mug up this, rub this. Now again symmetry about x-axis. That's why like this you have to draw. And rest of the curves, extra curves, you have to rub this. Now final curve is this. Okay, where these are the tangent lines. X is equal to y is equal to 0, x is equal to 0. These are tangent line. You have to write all these things. Okay, okay, and this is a special curve. You have to study well. Now let us see next. Okay, next point is oblique asymptote examples. There are only two examples are there, which is the examples of oblique asymptote. Rest of the points are same, only asymptotes are different. Therefore these are the equations you can mug up this equation. X cube minus y cube is equal to 3axy, and other equation is, other curve is x cube plus here x cube plus y cube. Just replace this by okay, first one is x cube plus minus y cube. We are going to study the result 3xy. Similarly, this is also example of x cube plus y cube is equal to 3xy. It's an oblique asymptote example. This is for homework. Okay, now let us see this example first. Okay, now the question is trace the curve x cube minus y cube is equal to 3xy. Now consider symmetry. If we observe this x and y power, both are non-even or both are odd. That's why it is not symmetry about the coordinate axis. Now next symmetry is put y is equal to minus x, or x is equal to minus y. We get from this equation, we get put x is equal to minus y and y is equal to minus x everywhere. Okay, this equation becomes like this, and minus cube is minus cube is minus becomes plus, and this minus becomes plus. The equations remains unchanged as it is. These are x cube minus y cube. This is also again x cube minus y cube. That's why the symmetry is about the line y is equal to minus x. What is the line? Y is equal to minus x. Let us draw this curve first, one by one. Okay. Now, first we have seen symmetry about the line y is equal to minus x. This is the line y is equal to minus x, which is exactly middle at this quadrant second and fourth. Okay. This is the line y is equal to minus, this is symmetry line. Okay. First time we are getting this symmetry line for such examples. Okay. Now, origin. Put x is equal to 0. We get y is equal to 0. Equation satisfied, therefore passing through origin. This curve is passing through origin. Okay. Now, point a tangent at origin. What is the theory for tangent? To find tangent at origin, lowest degree term should be equal to 0. What is the lowest degree term here? Here degree is 3, here degree is 3, here degree is 1 plus 1, 2. That's why this is the lowest degree term. It's equal to 0. And 3a can't be 0, therefore x is equal to 0 and y is equal to 0. Therefore x is equal to 0 is the equation of y-axis, y is equal to 0 is the equation of x-axis. That's why both the axes are tangent at origin. We have to draw the curve. This x-axis tangent at origin means this line. Okay. Obviously this also can be possible. Again y-axis is again a point tangent at origin. That's why it can be possible like this also. Okay. You have to draw in symmetric manners. Okay. This is the possibility. Now next, point of intersections. Put x is equal to 0, we get y is equal to 0. Put y is equal to 0, we get x is equal to 0. That's why we get only origin point. Now this is not necessary, but we have to write it, because we get, if we get the symmetry line apart from x and y axis, and then we have to find out whether the point of intersection of curve lies on this line or not. For that, put this line equation in the given equation of curve. Okay. Therefore, put y is equal to minus x. Where is come from? From symmetry line. Okay. In the above equation, what we get? X cube minus y is equal to minus x. Here y is equal to minus x here. Minus cube is plus cube. Therefore, it becomes x cube plus x cube, 2x cube, and it becomes minus 3x square. It becomes, now cancel out x cube, x square from both sides. We get 2x is equal to minus 3a. X is equal to minus 3a by 2. X is equal to minus 3a by 2 and y is equal to minus x. Therefore, y value becomes minus of minus, that is plus 3a by 2. That's why we get one point of intersection, that is x and y, that is minus 3a by 2 plus 3a by 2 on the curve, which is the, see, minus 3a by 2 and plus 3a by 2 we have to draw. If suppose a is there, what is 3a by 2? 3a by 2 is a half, 1.5, did 1.5 times a. Okay. If a, suppose if we draw, see, and minus 3 by 2, this one, minus 3 by 2 and plus 3 a by 2 point lies in which quadrant? Obviously x side is minus, x coordinate is minus, y coordinate is plus. That's why this point is lies between second quadrant, where x is negative and y is positive. In this line, the both 3a by 2, 3a by 2 is a same number but opposite in sign. That's why same number lies on obviously this line, because y is equal to minus x. Now on this line, this point we have to plot 3a by 2. Take a distance 3a by 2 x from x axis. Suppose this is 3a by 2. Okay. It is only by guessing. Suppose this is a, then this is 3a by 2. Okay. This is suppose 3a by 2. Now obviously this distance must be same as y. Suppose this is minus 0 minus 3a by 2. This is 3a by minus 3a by, this is plus obviously, minus 3a by 2, y axis is 0. That's why point becomes here. Point comes on this. This is the point, minus 3a by 2 plus 3a by 2. This is the point of intersection of the curve. Okay. This is just a plotting of point. Okay. Now this is the point of intersection of the line. Okay, understood? This is the curve we have so far we have just drawn. Now next, asymptote. See, this is an example of oblique asymptote. Obviously no asymptote parallel to x and y axis because coefficient of highest power of x is 1, which is not equal to 0. Coefficient of highest power of y is 1 again, minus 1, which is not again equal to 0. That's why no asymptote parallel to x and y axis. Now we have to calculate oblique asymptote. This is example of oblique asymptote. You have to mug up this example, which is example of oblique asymptote. And we already write all the theories of finding out oblique asymptote. Now this is the theory. See, put y is equal to mx plus c. This is the equation of line. Slope point form is there. Of line in the we have to put this equation in the given equation number 1. Call this equation number 1. Okay, given equation, and put y is equal to mx plus c everywhere. What do we get? X cube I have write already here. No asymptote parallel. Put y is equal to mx plus c in the given equation 1. What we get? X cube minus y value is mx plus c cube is equal to 3axy. Again y value is here we have to put mx plus c. Okay, in the next step we have put here. Now x cube. Now we have to use a plus b bracket cube. What is a plus b bracket cube? A plus b bracket cube is a cube plus 3a square b plus 3ab square plus b cube. Okay, this is the formula for a plus b bracket cube. What is a here? Mx. What is b? C. That's why it becomes m cube x cube plus 3 m square x square into this c plus 3 mx into this second term square, and plus last term cube is c cube. Okay, using this formula. Now RHS side becomes 3ax mx plus c. Now again multiply this term, we get, now take this bracket out, minus becomes plus, plus becomes minus. This is the term. Simplification is equal to 3a m x square plus 3axc. Okay, now what we have to do, this is simplification. Coefficient of 2 highest power of x we have to find out. Coefficient of 2 highest power of x and equate it to 0. What are the highest power of x? These are the underlined term. X cube and x cube are the highest power. Its coefficient is 1 minus m cube. It must be equal to 0. This is the theory. And second highest power is x square. These are the two terms of x square. And its coefficient is 3 minus 3m square c. Okay. And this term becomes on that side minus 3am is equal to 0. This is the theory. Now simplify this to get value of m and c. Okay. Here we have to use a cube minus b cube formula. What is a cube minus b cube? It is a minus b into a square plus ab plus b square. And similarly a cube plus b cube is, just replace here a plus b and here a square minus ab plus b square. These are the two formulas for regular formulas. Here we use a cube minus b cube, where a is 1, b is m. Therefore this is the expansion. Okay, now this we neglect because it comes to if you solve this for m, it becomes imaginary number. That's why we neglect this term. From this m becomes 1. Okay, now here from this second equation, 3m gets cancelled from throughout, minus 3m cancelled throughout the term, we get mc plus a is equal to 0. Now we already know m value is 1. That's why mc is equal to minus a. C is equal to, we want c now, minus a by m. M value is 1. Put here, we get c equal to minus a. Now put this m and c value here in the original equation we have start from. Y is equal to mx plus c. That's why y is equal to mx plus c gives y is equal to m value is 1, c value is minus a. It gives x minus a is the asymptote line. This is the theory of oblique asymptote. Okay, this is the only difference between other curves and this curve. Now we have to draw this line. How to draw this line? By plotting the points. Now take x on that side, or you can put like that as it is. To plot the line, we need only 2 points. here order pair. First put x is equal to 0. Now next put y is equal to 0. If we put x is equal to 0 here, we get y is equal to minus a. If you put y is equal to 0 here, we get x is equal to plus a. These are the 2 points from which we can draw the line. Okay, now we have to draw the line. See, first point is 0 minus a. See, we already draw this line 3a by 2. This is the distance 3a by 2. Okay, means 1.5a is the distance. दीड a हे डिस्टन्स आहे बरोबर. मग आता आपण ड्रॉ करायचं आहे पॉईंट 0 मायनस a, सॉरी बरोबर 0 मायनस a अँड a0. फॉर दॅट वी नीड a डिस्टन्स. इफ इट इज हे जर दीड a असेल तर ऑब्वियसली a केवढा असला पाहिजे, एवढा असला पाहिजे. ओके, तुम्ही कर्व ड्रॉ करताना बुकमध्ये नोटबुकमध्ये टेक अ स्केल. ओके, इफ इट इज 5 सेंटीमीटर असं काहीतरी घ्या म्हणजे तुम्हाला एक्झॅक्ट कळेल. इफ दिस इज 1.5 आहे देन दिस बिकम्स a. तेवढं डिस्टन्स तुम्हाला घ्यायचं आहे एक्स ॲक्सिसवर बिकॉज दिस इज द पॉईंट ऑन एक्स ॲक्सिस a0. दॅट्स वाय तेवढं डिस्टन्स घ्या. वी गेट दिस ऑन दिस साईड. एवढं कुठंतरी असेल इथं, राईट. दिस इज a0 पॉईंट. अँड दुसरा पॉईंट आहे 0 मायनस आहे. ऑब्वियसली कुठं असणार तो 0 वाय ॲक्सेसवर असणार, मायनस एक खाली असणार निगेटिव्ह. तेवढंच डिस्टन्स असणार जेवढं इथं काढलं आहे आपण, राईट. बरोबर स्केलने घ्या आहे. दिस बिकम्स 0 मायनस ए. ना आता ही लाईन कशी असणार ऑब्वियसली या दोन लाईनला जॉईन करून जी लाईन मिळते दिस इज अ स्ट्रेट लाईन विच इज असिम्प्टोट. ओके, नाव जर असिम्प्टोट असेल तर कर्व कसा असणार ऑब्वियसली दिस और दिस, this or this. Okay, now see here. आता आपल्याला ड्रॉ करायचं आहे कर्व अगेन बाय क्वाड्रंट वाईज. जर आपण म्हटलं कर्व इज सिमेट्रिक अबाउट द लाईन y इज इक्वल टू मायनस एक्स. ओके, फक्त y इज इक्वल टू मायनस एक्स ह्यालाच कर्व सिमेट्री आहे. अशाच वी कॅनॉट प्रेडिक्ट टँजंट मिळालेलं नाही आहे किंवा फर्स्ट कुठलाही पॉईंट ऑफ इंटरसेक्शन ऑन कुठेही मिळालेलं नाही ॲक्सेसवरती. त्यामुळे क्वाड्रंट वाईज आपण करू शकत नाही. सईड आहे असं काही सांगू शकत नाही. त्यामुळे आपण काय करायचं, वी जस्ट प्लॉट दी जो कर्व काढला आहे आपण ते ड्रॉ करायला सुरू करायचे. सी, दिस इज अ पॉईंट ऑफ इंटरसेक्शन म्हणजे कर्व इथून कंपल्सरी पास होतो आहे, राईट. अँड हा पॉईंट जोडायचा आहे आपल्याला या दोन्हीपैकी कुठल्या तर एकाला ऑब्वियसली. तर तो कसा जोडणार ऑब्वियसली या लाईनला सिमेट्री आहे, राईट. त्यामुळे हा कर्व असाच जाणार इथून ह्याला जोडला पाहिजे असा, राईट. आणि जर एक्स ह्या लाईनला सिमेट्री असेल तर ऑब्वियसली असाच जोडला पाहिजे. स्मूथ कर्व करायचा असा. ओके, हे झालं. आता ऑब्वियसली हे असं आल्यामुळं हा असाच असणार आहे, राईट. आता हे आपल्याला जोडायचं आहे या दोन्हीपैकी एक कुठल्या तरी ह्या सगळ्यांना. ऑब्वियसली हे जोडू शकत नाही कारण हे जर जोडलं तरी इथं कट होणार. त्यामुळे हे गेलं, ठीक आहे. आता हा जोडायचा आहे. ऑब्वियसली कशाला जोडणार, हा जर असा कर्व आला आहे तर ही लाईन अशी येणार. ऑब्वियसली ह्याला जोडू शकत नाही, असं जाऊ शकत नाही कर्व फ्री हँडने. तर तो असाच जाणार ह्या कर्वमध्ये, राईट. कारण हे कंपल्सरी असलं पाहिजे आणि ह्या दोन्हीमधलं एक म्हणजे खालचाच असला पाहिजे. तर ऑब्वियसली हा डिलीट करायला लागणार. आणि सिमेट्री अबाउट दिस लाईन त्यामुळे जसा असा कर्व काढला आहे तसा तो त्या साईडला पण असणार. त्यामुळे हे कुठं जोडलं पाहिजे, इथं जोडलं पाहिजे ह्याला फ्री हँडने. त्यामुळे हे सगळं खोडलं पाहिजे, राईट. त्यामुळे हा पॉसिबिलिटी पूर्ण जातो, हे पण पॉसिबिलिटी पूर्ण जाते. कर्व इज लाईक दिस ओनली. द फायनल कर्व इज this. Okay, where सगळं x axis, y axis, this is origin, this is the point 3a by 2 minus 3a by 2 3a by 2. Okay, this is the symmetry line लिहा सगळं. Okay, this is the asymptote. Okay, that's why it is like this. फ्री हँडने काढावा व्यवस्थित कर. ओके. यू डोंट नीड टू राईट ऑल दोज परपेंडिक्युलर्स. फायनल कर्व हा असा असला, आपला रफचा कर्व हा असा असणार, सगळ्या लाईन्स असणार. ज्या लाईन इम्पॉर्टंट आहेत त्याच लाईन काढायच्या. लाईक फॉर एक्झाम्पल असिम्प्टोट, एक्स ॲक्सिस, वाय ॲक्सिस, दीज आर पॉईंट्स. ओके, सपोज दीज आर पॉईंट्स A0 0 मायनस A, असे प्लॉट करा व्यवस्थित डिस्टन्सने. अँड this point, okay, this is a symmetry line, this is asymptote line, these are x and y axis. व्यवस्थित नाव द्या सगळे, ठीक आहे. Now this is the asymptote, oblique asymptote example. This is homework for you. Only difference is here फक्त पॉझिटिव्ह साईन आहे, बाकी सगळं सेम आहे. त्या मग कर येताना उलटा येतो फक्त. म्हणजे कसा येतो, इट इज लाईक दिस ओनली. हा जसा आलेला आहे त्याचा तो कर असा येतो फक्त, म्हणजे लाईक दिस. ओके, असिम्प्टोट लाईनचं इक्वेशन पण लिहायचं. y इज इक्वल टू एक्स मायनस ए. हियर एक्स प्लस वाय इज इक्वल टू ए, ही येते कर लाईन, ठीक आहे. दिस इज द आन्सर फॉर दिस. जस्ट द मिरर इमेज मायनस असल्यामुळे मध्ये, ठीक आहे. दिस इज अ होमवर्क फॉर यू. सेम सॉल्व करा, यू विल गेट दिस कर ॲज इट इज. नाव इन नेक्स्ट लेक्चर वी आर गोइंग टू सी ट्रेसिंग ऑफ कर इन द पोलर फॉर्म. आता आपण सगळे एक्झाम्पल बघितले आपण कार्टेशियन फॉर्ममध्ये, वेअर एक्स अँड वाय कार्टेशियन coordinates are there. आता बघायचं आर अँड थीटा, वेअर आर इज द डिस्टन्स, थीटा इज द अँगल. ओके, हाऊ टू ड्रॉ दिस कोर विल सी इन नेक्स्ट लेक्चर.